This set of videos will be about Section 5.1 in college algebra and content, exponential functions. Exponential growth models, if you have the equation y equals a times b to the kx, where b is greater than 1, a is greater than 1, and a is greater than 0, and k is greater than 0. There is no x-intercept. The y-intercept is 0a. The domain is all real numbers. The range is all real numbers greater than 0. So from 0, you would write that from 0 to infinity. And the horizontal asymptote is the x-axis because it does not cross the x-axis. It's decreasing on the domain and concave. An example where we would use that. Suppose the inflation is predicted to average 5% per year for the years 2012 to 2025. This means that item that costs $10,000 one year will cost 10 times 1.05 the next year. And in the second year, you'll take 10,000 times the 1.05 times the 1.05 again, or you'll have 10,000 times 1.05 squared the following year. Write the function that gives the cost for a $10,000 item t years after 2012. We have that $10,000 item. We'll say this is f of t, and we're going to take that times 1.05 to the t power. That becomes our equation. Next, they asked us to graph the growth model from t equals 0 to t equals 13. And I will believe for x, since we're starting with, or for y, since we're starting with 10,000, we'll go to 20,000. We need to graph this equation. So it's 10,000 times 1.05 raised to the x power. For the window, we'll use 0 to 13 as they tell us. And we start with $10,000. So let's start with that. And let's see what happens when we go to $20,000. So this becomes our graph. So here we have our graph again. We went from 0 to 13 and 10,000 to 20,000 for our y values. You can see it didn't quite double in that time, but it come close, and it's growing, and you can see a little bit about its concave in this section. Cost 10,000 in 2012. Use the model to predict its cost in 2025. So let's take that. Our cost, f of t, that'll be 13, equals the 10,000 times 1.05 to the 13th. And when we grab our calculator to the nearest penny, it's $18,856.49. So it hasn't quite doubled in value in that 13 years, but it has come close. Now this is an exponential decay model. A is still greater than 0, B is still greater than 0, but K is now less than 0. Or B can be between 0 and 1, and K is greater than 0. So either K is less than 0 or B is only a fraction less than 1. There's still no x-intercept because the x-axis is an asymptote. The intercept is still 0a. The domain is all real numbers, and the range is y greater than 0. So 0 to infinity. Horizontal asymptote is the x-axis, and it's still decreasing on the domain, but is still concave up. Here's a case where exponential decay happens. Pays to advertise, and it is frequently true that weekly sales drop rapidly for many products after an advertising campaign ends. This decline in sales is called sales decay. Suppose the decay of sales is given by S equals 1,500 times 2 to the negative 0.6x dollars, where x is the number of weeks after the end of the sales campaign. Use this function to answer the following. What is the level of sales when the advertising campaign ends? In that case, when that advertising campaign ends, x equals 0. If we fill that in, we'll have 1,500 times 2 to the negative 0.6 times 0. Well, that'll make it 2 to the 0. And when the advertising campaign ends, the sales are at $1,500. Same thing. What is the level of sales 1 week after the end of the campaign? Well, in this case, x will equal 1. So S equals 1,500 times t to the negative 0.6 times 1. And when we calculate that, we find that the sales are already at $989.63. So 1 week ago they were 1,500, now they're less than 1,000. Graph to estimate the week in which the sales equal 500. So I have graphed this. I used x values from 0 to 10 and y values from 0 to the 1,500 we started at. Notice where it worked at 2.6. So in 2.6 weeks, the sales already dropped to a third of what they were in the advertising. So it really does pay to advertise. According to this model, will they ever fall to 0? And the answer to that equation is because our graph is an exponential function and the x-axis is an asymptote. The answer to that question is no, but they're going to get very, very small. They're saying maybe occasionally somebody will buy one, but not very often. This equation is for the future value S of an investment P for T years, the interest rate compounded continually. This is an interest rate that's compounded continually, and we use the value E. So S equals P times E raised to the RT power. If 10,000 is vested for 15 years at 12% compounded continually, what is the future value of that investment? So my S will equal the 10,000 is the principal that we start with, times E raised to the RT, so 0.12 times 15. And when I use my calculator, I find out that in 15 years, this investment has grown to $60,496.47.